Hey folks, good evening. How's it going? This is Mr. Moray coming to you with a video on analyzing functions, okay? In this video, I'm going to go ahead and explain to you a few different things. I'm going to go through, again, the things we're going to look for when we're doing analysis, and then I'm going to go ahead and do a couple of examples with you, okay? So hopefully, if you look down in the description for this video, you're going to see a few things. One, I will post a document with links to sheets with all the examples that I'm going to do in case you want to print those out to do those along with me. And also in the description, I'm going to try to put some timestamps so you can kind of skip through this and go through it at your leisure. I recommend that you have the worksheet out because we did do this as notes in class. This says 213, okay? This year, 2019-2020, this was 2-4, okay? And if you go to the Binder website, this is where I got this one. It just happened to be last year I did this 213. This year it was 2-4, okay? So I'm going to start by talking about analyzing functions. What do you need to know? What are the things we're going to be looking for when we're analyzing, all right? So the first thing is we're looking for domain and range, okay? So the domain is the interval of all of the inputs, or x values, while the range is an interval of all outputs, or y, or you could say f of x values as well, depending on the notation you use, okay? You're going to see that I circled I or p because it's really important that you differentiate between when are these things intervals and when are these things points, okay? Intervals look like points, but they have a different meaning, right? So when I see 1, 10, all right, it's important that you know, is it a point or an interval, because they look the same. If it's a point, you're talking about a point whose x is 1 and y is 10, okay? Point. Interval, you're talking about all the values that are greater than 1 and less than 10. So like if you don't put a hard bracket on either side, right, that's going to look different, right? Now if I put a hard bracket on 2, 3, you can see this as an interval rather than a point, all right? So what I'm trying to get at is the intervals and the points look similar, so you want to know that, all right? X-intercept and y-intercept. So we've hopefully learned by now x-intercepts are one or more points where the graph touches the x-axis, right? The horizontal axis. Remember, the x-axis more generally is known as the horizontal axis, and y-intercept is a point where the graph touches the y-axis, or vertical axis. Now remember, we talked about the fact that there's always going to be only one y-intercept, because if these are functions, remember, how many outputs can an input of a function have? Right? It can only have one output. So therefore, since the y-intercept is what you get when you plug in 0 to the function, right? That's what it looks like graphically. When you plug in 0, only one thing can come out. Therefore, there can only be one y-intercept. Okay? Now, remember, these three are the three trickiest ones. Remember, big thing, they're x values, but they're referring to y values, okay? They're intervals of x values, so that with increasing, as we go from left to right, y is going up. Here's an example. Let's look at this one right here, okay? Increasing, okay? Decreasing, on the other hand, remember, ditto, intervals of x values where y goes down from left to right. So here's one interval, two intervals, three intervals where I go down from left to right. Okay, remember, we're always going left to right because x always increases from left to right. And finally, constant is intervals of x values where y stays the same from left to right, okay? And so this one right here, this would be a constant, all right? And we're going to learn how to talk about those in just a minute, okay? Positive and negative, again, the confusing part is they are x values talking about y values, because remember, the x controls the y, right? The x is the independent variable. Y, or f of x, depends on x. Okay? So the positive is intervals, one or more, of x values where y or right? We could also say f of x is positive or greater than 0, and intervals of x where y or f of x is greater than, or is less than 0 rather, right? Positive versus negative, right? To be positive means to be more than 0. To be negative means to be less than 0. So if I go ahead and I shade this in, just a little darker, we can see a few places where it's positive, right? Here's one place where we're positive. Here's another place where we're positive. And where we're negative, here's one place where we're negative because the y is less than 0. It's underneath the x-axis. And here's another little place where we're negative, okay? Sometimes you've got functions that are always positive. This function here is almost always positive, except maybe for this one little intercept. So it's almost always positive. Some functions are always positive. Here's another example. I'll come down here. Here's a little v. Here's a little absolute value, right? This guy right here, it's always positive, and that's okay. Some are always negative. Okay, here's one that's always negative. That's also okay. All right? Another place where we get stuck is with absolute versus local extrema, or minima and maxima. Okay? So, and notice, the versus a. So, there can only be one of them. Absolute maximum of a function is the absolute highest point on the graph. There can only be one. All right, this was asked today. If you see a wave, this does not have an absolute max because there is no one highest point where it hits a maximum. That's how I'm going to define it. So an absolute maximum versus this is an absolute maximum because this is one highest point that it reaches. So this has no abs max, right? Now remember, when I say point, that means I want to see an x and a y. X, where is it? Y, what is it? Okay? Similarly with an absolute min is the absolute lowest point on the graph. All right? This is an absolute minimum right here. Absolute minimum of 0, 0. The lowest point this function ever hits is 0, 0. Now note, not every function is going to have one. Here's one with no absolute max. The arrows point up on both ends, right? Arrows pointing up, meaning it goes up and up and up and up and up forever, and you're never going to hit a highest point, right? Someone said today, oh, I'm gonna find the biggest number ever. And remember what I said to that person? I said, look, you give me the biggest number you can think of. I'll just add 1, and I'm going to get a bigger number than that. All right, so you're never going to have, if you're going up and up and up, you're never going to have a max. If you're going down and down and down, you're never going to have a min, absolute max or min, and that is okay. Here's where a local max and local min are different. So first of all, notice the word a. That's because you can actually have as many local maxes as you want. Here, because look, a local max is any point where the graph goes from increasing to decreasing. Let's take a look at this. So I'm going to magnify the wave. Here's a wave function. This is also called a sinusoidal function. Notice that here, and here, the function's going up, 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 hits the top, goes down. Up, 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 hits the top, goes down. Up, 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 so everywhere that this hits a peak, that is going to be a local max. Ordinarily, right, you're going to have a coordinate plane and you're going to define those exact points, what they are. A local min is any point where the graph goes from decreasing to increasing. We call these valleys, all right? Right? So we're going down, 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 up, 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 okay? All right. Finally, two things. End behavior. The end behavior is what happens to y when x gets really, really far from 0 either way, right? So as x goes to infinity, what's happening, right? So we say the limit as x goes to infinity, right? Or as x goes to infinity, or I'll bring this down here. We say the limit as x goes to negative infinity, okay? Or as x goes to negative infinity. We should put an x there. what's happening? Is it going? And remember, there's going to be three cases of end behavior. Either f of x goes to infinity, f of x goes to negative infinity, or f of x goes to a constant, okay? And in this video, you're going to see all three examples of end behavior. With regard to, you're going to see going to positive infinity, negative infinity, and a constant, okay? So when we're looking through these, remember, you got to know a couple things. One, what the heck do they mean? That's why I'm giving you this sheet, right? In the beginning, we're going to have to think about this, but eventually you are going to have to be able to know how to identify these features. Two, when I ask you to give me something, what do you need to give me back, right? Is it an interval? Is it a point, right? A lot of these things are intervals, but some of these things are points, okay? And then once you've identified that, what information do you need to supply, okay? Is it x values? Is it y values? Is it an x and a y? Is it multiple intervals, okay? So, or points, okay? So remember, all of these are intervals of x values. The domain's an interval, any interval that is. So the domain is an interval of x, increasing, decreasing, constant is an interval of x, positive and negative intervals of x. The only time that you're going to use an interval of y's is with regard to the range, okay? And the range is an interval of y or f of x values, depending on what notation you use. Okay, so this is just a little bit of an intro again on the terminology. I'd recommend if you need to go back to kind of walk through some of my explanations here, go ahead and do that, okay? And then in a few seconds, I'm going to go ahead to our first example. All right, so I'm going to start with a little example of end behavior. I'm going to do the whole function analysis in general. I'm going to do it using pencil just in case there's any mistakes, and those are perfectly fine. Before I move on, remember, not every function will have all these things. Like I said, some functions never increase. Some functions never decrease. Some functions never have a min or a max at all. Some functions don't have an axis of symmetry, right? A line that the function can be folded over onto itself. And that's perfectly okay. All right. Okay, so I'm going to start with this function right here. This is f of x equals x cubed. For each of the functions I'm going to talk about today, I'm going to go ahead and give you their formula. The formula is not super important that you know it, but actually there is some really cool stuff to note. Notice how the biggest power of x is 3, and that's an odd number. Observe the end behavior is in opposite directions. That's going to be true whenever the biggest power of x is an odd number, okay? The end behaviors will generally be different. Think about a line, mx plus b, biggest power of x 1, right? All right. Let's talk about domain, range, etc. So let's start with this. Let's look at the domain. So I'm looking through the domain. It's a nice solid curve. It's what we'd call continuous, right? I can trace over the whole graph without picking up my pencil. There's no holes in the graph. There's nothing that would restrict the domain or prevent it from being everything. So the domain is negative infinity, comma, infinity, okay? Negative infinity, and I'll zoom in so help you see that a little clearly. Because I'm using pencil sometimes, it doesn't come out perfectly on my because I use a flash in there too. All right, so range. Let's look at the range. What are the y values here? Notice an arrow pointing down and an arrow pointing up. That means all the negative values, they're going to get hit. Now, it doesn't look like it, but as we continue to move out this way, the y values will continue to move down this way. So it's pointing down. There's no top point to it, or rather bottom point to it. On the top, up, 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 up forever, there's no indication. So basically, the range is also negative infinity to infinity. Here's my promise to you. If the domain and range are not everything, that is, they're not negative infinity to infinity, okay, it's going to be really clear. I've got to show you clear evidence of that in the graph. And you're going to see what that looks like when we do some more examples. But unless I show you that evidence, okay, and you can clearly see evidence that the range is not everything, you're going to assume it's everything, okay? That's basically my best explanation there. So also, remember that you never put a bracket, a hard bracket, on infinity, okay? The reason you never do that is because infinity means it's going on forever in the positive direction. Negative infinity means it's going forever in the negative direction. To put a hard bracket on it is kind of like to say, nope, it's got to stop at some point, right? And we know that that's never really going to happen with infinity. It's going to keep going on forever and ever. And infinity, right, is not really a number. It's like a concept. It means make it as large as you want in this direction. Make it as low as you want in that direction. It's all good, okay? We're not putting any restrictions on it, all right? So remember, no brackets on infinity ever. Only parentheses, soft brackets. All right, where is it increasing? So let's look as we go from left to right. Now, the biggest mistake people make is like, hey, Mr. Murray, what's up? But look, it's going down, right? It's going down. So it's decreasing here. No, let's go from left to right. As x is going up, as we go from left to right, what's happening to y? It's going up, right? Example, plug in -2. -2 cubed is -8, right? Plug in -1. -1 cubed is -1. See, we went up. Then we go to 0. Then we go to 1. Then we go to 8. So as x goes up, y is always going up. So this function is increasing everywhere from -infinity to infinity. Where is it decreasing? Well, it's never decreasing. It's decreasing nowhere. So you can put a circle with a line, which means empty set, because these are technically considered sets or collections of numbers. So you could say empty set, or you could say NA. Not applicable, never decreasing. Constant, same thing. There's no point where the function values are staying the same from left to right, okay? What about an axis of symmetry? Is there a line that we can cut this thing through such that it will fold on top of itself? Well, technically this thing is what we'd call symmetric about the origin. If I was to reflect this about 0, 0, it would go on to itself. But there's, right now, for these kinds of functions, we're going to say there's no axis of symmetry, NA. There's no line that we could reflect this thing over onto itself. We might learn something different, but we're not going to delve deep into cubics this year. So if that's something we talk about in the future, maybe in course 2, I'm going to put it off until then, all right? All right, what about positive, negative, and that stuff right there? So look, what x values is this guy going to be positive? Well, let's take a look. When I start at 0, nothing, right? Now remember, you don't include 0, right? Because 0 is 0. Nothing positive, nothing negative. But from 0 onwards, notice what are the y values? They're positive, right? 1 is 1, right? 2 is 8. A half would be 1/8. A quarter would be a 64th, right? As I get closer and closer, right? All these are positive, right? But starting lower than 0, they're negative. So what are my positives? 0, comma, infinity. Okay, you never include an intercept because an intercept, like an x-intercept, is a place where it is 0, and 0 is neither positive or negative. If you include, put a hard bracket, you're not getting full credit because you are saying something that is not correct. You're claiming that 0, y is positive. No, 0, y is 0. Okay, I'm going to be really picky about that. Negative, where's the function negative? Well, it's negative from when x is equal to -infinity, all of the negative values of x, right? -1, it's negative. -2, it's negative. -3, if you plug in -3, you get 27. 4, because you're cubing. 4, you get -64. -125, etc., etc. So these are going to be all negatives, and it's going to make y negative. How do we say it? We say -infinity to 0, right? From when x is -infinity to when x is 0, okay? Again, you're not including 0 because 0 is a point where y is equal to 0, or f of x. So again, if you include that, you're going to lose points. That's not true. X-intercept or intercepts. Where does it touch the x-axis? Well, it touches the x-axis at the origin, 0, 0. Okay, I'm going to erase this because remember, we know there can only be one y-intercept. And again, it touches the y-axis also at 0, 0. Sometimes they'll be the same, right? Sometimes an x-intercept will also be a y-intercept. That's okay. Let's look at end behavior. So as x goes to infinity, as x gets really, really, really big, right? Let's think about plugging in 10. You get 1,000. Plug in 5. You get 5. So let's go the other way, right? Plug in 1. You get 1. Plug in 2. You get 8. Plug in 3. You get 27. Plug in 4. You get 64. Plug in 5. You get 125. Plug in 10. You get 1,000. Notice as the x's are going up, the y's are shooting up explosively. Notice the arrows pointing up. So, as x goes to infinity, and you could do the infinity first or the negative infinity first. It's the same either way to me. You do whatever you want. So, when you write end behavior, I recommend you get in the habit, okay, if you're going to write it this way, of writing out the shell. This is the shell. When this part that you see here is always exactly written like this. Anytime you do end behavior, this is always going to look like this. As x goes to infinity, f of x goes to. As x goes to negative infinity, f of x goes to. Always going to be the same, right? So you could almost create a little shell here. It always looks like this. Now, let's fill in what happens. So as x goes to infinity, f of x is going, based on our arrow, pointing up, infinity, okay? What about as f of x goes to negative infinity? What's happening? Well, our arrow says down, 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 down. Negative 1, negative 1. Negative 2, negative 8. Negative 3, negative 27. Negative 4, negative 64. Negative 5, negative 125. Negative 6, negative 216. Negative 10, negative 1,000. And I just happen to know these numbers off the top of my head. But if you had the function, you could plug these in too. So what we know is that, look, they're getting more and more and more negative, and as x is going to negative infinity, f of x is going to negative infinity. How do we write this with limits? Okay, so the limit as x approaches infinity of f of x equals infinity, okay, and then the limit as f of x, as x approaches negative infinity of f of x is equal to negative infinity. So remember, two options. Either you write it like this, or you write it like this. You do one or the other. Don't do both, because if you do both and you don't do one of them right, you're going to lose points, right, for trying to get a little bit too cute with it. Don't get cute with it. Do one or the other. The limit way, beautiful. Not required, calculus-based, mathematically correct, or statements, your choice, okay? But what you got to capture is as the x values are getting really, really large, really, really far from 0 in the positive direction, shooting up. As x is getting really, really far in the negative direction, x is shooting down, okay? So I really invite you to go back and take a look at this in-depth explanation of this function, okay? And all the features that I analyzed. And then when you're ready, I'm going to go ahead and move on to the next one. All right, I'm going to move to the next one. You might have noticed I didn't do any mins and maxes. This one didn't have any, and that's why I kind of did that. So I'm going to go ahead and move on to one. And in this one, we will talk about minimums and maximums. Or I guess I should say minima and maxima. So this one's a quadratic, all right? This is f of x equals negative x squared plus 4. Notice that it's a sad face. I've got a negative number up in front of the in front of the x squared. It points down. It actually follows a really cool pattern. It goes down by 1, then by 3, then by 5, then by 7, then by 9. So if you can learn some of these patterns, I'm really excited to talk about quadratics at a later point with you guys. So let's talk about domain. Again, domain, notice, no holes, right? Remember, when you see the arrows, you know, like, it's good after here, right? If it's good here, it's good there, right? Because this, we can just assume it's just going to continue the same way it's going. So the domain, again, everything, it's all good. Everything's good, okay? Now, the range. Let's talk about the range. So, pointing down, 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 down. Okay, so what's the highest we can go? So we're good here, we're good here, we're good here, we're good here, up. So we can go as low as we want. Again, the arrows indicate that. Negative infinity. What's the highest we can go? It's 4. Okay? What goes on the 4? It is a closed bracket on the 4. Okay? Really, really important. All right, how about increasing, decreasing? So as we go from left to right, where the y is going up, where the y is going down. It's helpful to have a sense of where your maxima and minima are, because those are the cutoffs between where it's going up and where it's going down. So if we take a look at this, right, we see that we have a maximum right here. And notice how left to right, we're going from left to right. So we're going up, 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 up. And I know it points down, but we're going left to right right now. So going up, 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 up. All right. So here we are. Now, are we going to write negative infinity to 4 or negative infinity to 0? Are we going to write negative infinity to 4 or negative infinity to 0? We're going to write negative infinity to 0 because, look, remember, these are x values. So from when x is all the way down to negative infinity, as low as we want, if we go from left to right all the way to 0, the y's are going up, okay? You're not using the y values, you're using the x. Remember, the x determines the y, okay? Decreasing. So where is it going down? So we get here, then it's going down, 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 down. From 4 to infinity or from 0 to infinity? It is from 0 to infinity, we're decreasing, right? From when x is 0 to 1 to 2 to 3 to 4 to 5 to 6 and so on, we're getting smaller, right? So for example, 1 is 3, 2 is 0, 3 is negative 5, 4 is negative 12, and so on and so on. Notice as I'm going up, smaller, smaller, smaller. Again, let's look at the other way, right? So here, 3 is negative 5, right? Negative 3, rather, is negative 5. Negative 2 is 0, so that's more. Right? Negative 1 is 3, that's even more. Okay, we get up here, even more. So left to right, it's going up. Left to right, it's going down. Where is it constant? It is constant never. It's never constant, okay? Axis of symmetry. Is there a line such that we can take the graph and fold it over on itself? And there is, right? Okay, it's this line right here. And this line is x, because it's an up and down, it's a vertical, equals 0, okay? Absolute max or min. We do have one. We have an absolute max, no absolute min. We do have an absolute max. Max at, I need an x and a y. X is 0, where y is 4. What? Okay, it's an absolute highest point. The fact that I have arrows pointing down tells me there's never going to be an absolute min. Never, never, never. If you give me a value, you plug in like, I don't know, 3, right? You get, what, negative 5. If I plug in 4, I get negative 12, right? If I plug in 5, I believe I get negative 23. Something to that effect, or negative 21 or something like that. If I plug in 10, right, I'm going to get negative 96. I can do that really quick, right? Negative 100 plus 4. So the more and more, you're never going to get to a smallest point. If you plug in the number 100 for x, I'm just going to plug in 101. I'm going to get a smaller answer. You plug in negative 100, I'm going to plug in negative 101 again. So there's never going to be a lowest point, all right? So again, downward facing arrows tell you no absolute min. Upward facing arrows tell you no absolute max. Provided that the both arrows point in the same direction, that will definitely be true. But in general, any arrow pointing down or up, down, you're never going to have absolute, even if it's just one side. This doesn't have an absolute min either, right? As long as there's an arrow pointing in a direction, it's pointing down, there's not going to be an absolute min. Pointing up, there's not going to be an absolute max, okay? Where is this thing positive? Let's take a look. So I'm going to trace this with my green pen. Okay, notice how here's where it's positive. from -2 to +2. Remember, do we include the endpoints? We do not. -2 to 2. Because what is the y value here? It's 0. 0 is not positive or negative. Negative. Here's where we're going to get into a little bit of technicality. So where is it negative? Well, it's negative in two places. Right? When x is less than -2, meaning from -infinity to -2. That's true. It's negative, right? Or from 2 to infinity. Okay? And remember, and I don't know if we've talked about this, but remember to take two things and stick them together like this. You're going to write U. U means union, like a union of two people. You bring two people together, like marriage. You're bringing two people together. They're separate, but you're bringing them together. You're connecting them. Union, you take two sets. These sets aren't attached. There's no overlap. The union takes them and it sticks them together. The U is the glue. All right? So there's the negative. X-intercepts, there are two of them. Notice, interestingly, -2, 0 and 2, 0. Observe how the x-intercepts are reflected in the negative and positive intervals, right? The cutoff points are always going to be your x-intercepts. And if you think about it, that makes sense because your x-intercepts, okay, are the points where it's equal to 0. So you've got like a negative, it hits 0, that's the cutoff, then it goes positive. Then it comes back down, it hits 0. So it's almost like the gatekeeper there, okay? Y-intercept, where does this graph touch the y-intercept? It is at 0, 4. All right, end behavior. So I'm going to do it in the written out way, right? As x goes to infinity, f of x goes to -infinity, downward pointing arrow. Okay? Notice I did the infinity first, positive. Remember, you could have done the -infinity first. That's okay. And as x goes to -infinity, f of x also goes to -infinity. So see how on this one, we actually had opposite end behavior, odd power. This one, even power. End behavior is exactly the same. Okay, sorry if I was shaking a little bit there. So as x goes to infinity, f of x goes to -infinity. As x goes to infinity, f of x to negative. As x goes to -infinity, f of x also to -infinity. One thing I left off, any local maxes or mins. So is there any place where y goes from increasing to decreasing? No mins, but there is a max, okay, at 0, 4. And you're going to be like, Mr. Murray, what? These are the same. But if you think about it, every absolute max is also a local max, okay? Because remember, think about how he defined it. An absolute max is the absolute highest point. And it is true that 0, 4 is the absolute highest point. However, we also defined it, a local max, to be any point such that we're going from increasing to decreasing. Observe how at 0, we go from increasing to decreasing. So notice how my local max is reflected in my increasing and decreasing intervals. So that's actually okay, all right, to have it set up that way. So folks, I'm really going to encourage you to go ahead, go back and take a look and make sure this makes 100% sense to you, okay? And then when you're ready, I'm going to move on to another one. All right, you guys definitely been patient at this point. I know we're hitting over the 30-minute mark. Here's what I'm going to do. I have the function f of x equals 2 times the absolute value of x minus 2 minus 2. I'm going to ask you, I'm going to pause the video, okay? Let me zoom out. Okay, I'm going to pause the video, okay? This is what I need you to find. Get that in the view. I'm going to pause the video. I'm going to ask you, okay? Pause your video on your end. Answer every single bit of information. And then when you're ready to check your answer, unpause, and I'm going to solve it for you. All right, here we go. I'm solving this one for you, and I'm doing this because we've talked about absolute value in class. And we've done one of these in class, so I'm pretty confident we can do this. All right, let's first with domain. Again, we see no holes, we see no signs of an not complete domain. So the domain is negative infinity to infinity. If you could technically, this is another thing sometimes people do. They do an R. This means all real numbers. If I don't say, give me the interval that is the domain, if I don't specifically ask for an interval, and it's a free response, like open response, fill it in, you could say all real numbers or the double bolded R. That's okay with me. If I don't specifically say an interval, technically speaking, I guess you won't have to do that. Range, what's the highest value? So let's look. Let's run our pencil. Okay, lowest value, here we go. -2, highest value, infinity. So the range, hard bracket on the -2 with a soft bracket on infinity, because it goes as low as -2, as high as we want. Increasing. Now, notice from left to right, down, 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 up, 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 up. So here's my challenge. Is it negative infinity to -2 or negative infinity to +2 for the decreasing? Okay, it's decreasing from negative infinity to +2, because remember, we're always talking about the x values, okay? We're talking about the x values, all right? And it's increasing from 2 to infinity, okay? As it turns out, constant is a trick question. So again, from when x is 2 to up, increasing, decreasing, okay? Axis of symmetry, we've got one, okay? It's x is equal to 2. Observe how you have the vertex here of 2, -2. Observe how the x of the vertex is the same number that appears there. That's something that you might want to think about, because that's going to be true of absolute value and quadratic functions. All right, absolute max or min. There is no max because of the upward pointing arrows. There is a min, and remember, the vertex is always a max or a min. In this case, it's a min, right? If this number is positive, it's going to be a min. If it's negative, it's going to be a max. Again, think about these patterns, because it's the same exact idea with quadratics. If this is positive, it's a happy face quadratic, it's a min. If it's negative, it's a sad face quadratic, it's a max. Okay. Now I'm going to come up here. Positive, negative. Where is it positive? Okay, so let's take a look. Here's where it's positive. I recommend you think about tracing over. If you want to use different colors on a test or a quiz, as long as you know there's limited time, it's fine with me. Here's the positive part. So from x equals 3 to x equals infinity. So there's 1. So from 3 to infinity, and from negative infinity to 1. Okay? Those two intervals. Negative infinity to 1, 3 to infinity. Okay? Where is it negative? Well, it's negative from when x equals 1 to when x equals 3. So it's negative from 1 to 3. Okay? How about x-intercepts? What are my x-intercepts? They are 1, 0, and 3, 0. Here you can just write them out. 1, 0, 3, 0. Notice how don't write a U, because there's not a union. It's not a set. It's 2 points. See, that's the tricky part, right? Numbers like sets and points look alike. But remember, I know that if it's negative or positive, I'm looking for an interval. Okay? Here I'm looking for points, so please don't put a U there. Okay, what's the x-intercept? It's kind of hard to see, but based on the slope, remember, up 2 over 1. The y-intercept, I hopefully said y, I think I might have said x, is 0, 2. Okay? End behavior. As x goes to infinity, f of x goes to infinity. It's pointing up. Okay? And this is true of basically any absolute value. As x goes to negative infinity, f of x is also going to infinity because pointing up this way and this way. Right? Last but not least, local max or min. Again, no local max, but there is a local min at 2, negative 2, because at negative 2, the graph goes from, or rather of 2, at 2, the graph goes from decreasing to increasing. So it's a local max or local min. Remember, every absolute min is also a local min. Every absolute min is also a local min. Okay? So I really encourage you, if you didn't get this 100%, please go back and take a look at it. Please, please, please. Okay? In a moment, I'm going to move on, and there will eventually be another you try that I encourage you to look at. All right. Now I'm going to move on to a piecewise defined function. This is a piecewise function. So it's such that f of x is equal to 4 when x is less than negative 5. It's equal to x plus 3 in parentheses squared when x is between negative 5 and 0, inclusive of both sides, okay? And it's 3x minus 5 when x is more than 0. The formula doesn't technically matter, and on a test or quiz, I may not even give you the formula. I don't so much care about the formula as much as I care about your ability to read the graph, okay? So again, let's look at the domain, the range, etc. The domain, think about this. The domain is still everything. No matter what you plug in, you know that you're going to get an output. If it's anything up to negative 5, you can plug it in. Use this rule. If it's anything between negative 5 and 0 inclusive, you got it. Use this rule. If it's anything more than 0, you got it. Use this rule. So this has a domain of, again, negative infinity to infinity, okay, or all real numbers. Okay, range. What's the range? What's the lowest? Okay, now, here, 1, 2, 3, 4, negative 5. Is negative 5 included here? It's not, because it's an open circle. So you do need to make note that negative 5 is not included. What's the highest it goes? Infinity. This arrow indicates it's going to point on forever. Okay, the piecewise is tricky. Where are we increasing? All right, so we are increasing from a couple points. Negative 3 to 0, we're increasing. And from 0 to infinity, okay? Or, yep, from 0 to infinity. Now, you could really say from negative 3 to infinity. To me, it just doesn't feel right because you've got that drop. This feels better for me, okay? And again, piecewise is a little bit different. So, you know, these are little technicalities, all right? So I'll be flexible in this case with a piecewise function. Where are we decreasing? One place, from negative 5 to negative 3. And now, finally, here's a place where we're constant, right? From negative infinity all the way to negative 5, we are constant. Okay? Notice how I stitch these together. I get the full domain. One part, the next part, the next part. So we stitch it together, we get the entire domain of all real numbers. Okay. Absolute max or min. Does it have an absolute max? It doesn't, because this points up to infinity. Now, technically, it also does not have an absolute min because this is an open circle. So this is actually not applicable. There's no max or min. There is a local min. Now look, remember, this is a max. It seems like it's a local max, but we jump back down here. I don't feel comfortable with you calling this a local max. I know it's weird. It's piecewise, but I'm not okay with this. This is okay with me because look, this is constant to decreasing. Can't do that. But look, decreasing, 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 increasing, increasing, increasing. So we have no maxes. We have a min at -3, 0. Okay? No axis of symmetry. Positive. Where is the function positive? Wow. Okay, so it's positive from -infinity up to 8 or up to 0. It is up to 8, okay? That's one part of it. So the first part is from -infinity, not to 8, to 0, okay? The 8 is where people get confused. So y is 8, but the x is up to 0. Where else? Let's take a look here, the 3x minus 5. So technically, this is 5/3. If I make 3x minus 5 equal to 0, right, and I add 5 on both sides, and I divide by 3, I find out that the intercept is 5/3. So don't guess on this, okay? So the other place is from 5/3 to infinity, okay? Those are the two positives. Where is it negative? Well, it's negative from 0 to 5/3, okay? All right, x-intercepts. Again, we have 2, -3, 0. And actually, I believe this is a 9 up here. So I shouldn't have said 8. I should have said 9. Because if you plug in 0, you get 9. And the other intercept is, we just talked about, 5/3, 0. I almost recommend, if you want to actually get your x-intercepts first, you actually might find it's really helpful for finding your y and your positive and negatives. Because again, notice how the -3 is going to show up in your... well, in this case it doesn't, but your 5/3 is going to show up there. And your -3 actually shows up in your increasing and decreasing. So there's a lot of these things that tie in. All right, y-intercepts. We have 1. When you plug in 0, you get 9. All right, finally, end behavior. This one's tricky. So as x goes to -infinity, what happens? It locks in flat. Notice, completely flat line. And because it's an arrow, that means it's flat forever. Flat, 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 flat. So it means, all right, what's the y value here? It's locked in at 4. So you see a flat line, you see it locking in, you have to use the number it's locked in at. Okay, so it's locked in at 4. So when you see a straight horizontal line, that thing has got no slope whatsoever. You look carefully, you see that. That is a flat number, a constant end behavior. Okay, and as x goes to positive infinity, analyze f of x to infinity and beyond. Okay, so again, folks, I really highly recommend you take a second, go back and process that. Okay, think carefully about that one, and then in a minute, I've got another you try for you. All right, folks, again, really love the persistence. I know this has not been easy. I'm going to throw another little piecewise at you guys. Now, I know the U-tries have both been piecewise, but this is because of where we're at right now. This is our stage we're at, right? We just are getting our feet wet with analysis, so that's why I'm sticking with what we've seen before. This is f of x equals -1/2, an absolute value of x plus 1 plus 2. Be really, really careful when you look at this graph, okay? Because this is -1, 2, okay? Then notice I'm going over 1, and then I'm going to go down 1, over 2. So this is -4, 0. This is 3, 0. -4, 0, 3, 0. -4, 0, 3, 0. -1, 2, okay? So take a second, pause the video, and then when you're ready, unpause, and I'll show you what the answer is for this problem right here, the full analysis. All right, I'm ready to go into this. Let's do it. So let's zoom in and I'll show you what we're doing piece by piece. Domain, the first piece, the domain here, negative infinity to infinity, full domain. Everything's working. Range, low to high, low, 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 up, 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 stops. Notice how the vertex plays in, right? The vertex of negative 1, 2. The range goes from negative infinity to positive 2. Lock in. All right, increasing. It's increasing from where? From negative infinity to 2 or from negative infinity to negative 1? It is from negative infinity to negative 1. Remember, it's x values, and then it's decreasing from negative 1 to infinity. Okay? Where is it constant? Nowhere. Does it have an axis of symmetry? Yes. Its x is equal to negative 1. Remember, in this case, it's always an x because it's an up and down. All right, any absolute maxes or mins? There's no min, but there is a max. Okay, and that's the vertex, negative 1, 2. And there also happens to be a local max. Okay. Positive. Where is it positive? So remember, I told you, and this was supposed to be a helpful hint here. So we have negative 4, 0. And this is 3, 0. Okay? Because think about it. We plug in 3, 4, negative 2, 0. Okay? And actually, let's just make sure. So negative 1, negative 3. I'm sorry. This is not negative 4. Because, let me see. So I have negative 1, 2. Then I've got, it goes down to 1, over to 3. Yeah, I'm sorry. This should be a 5. Okay? So if you caught that, good. If not, just take a second and pause and adjust your answers if needed. It's a negative 5, because negative 5 plus 1 is negative 4. Absolute value 4 times a half is negative 2, plus 2 is 0. So if you need to take a second to fix it, go and do that before I talk about the rest of it. All right, so where is it positive? It's positive, and I really recommend you do the colors. Okay, it's positive from negative 5 to positive 3. Okay, it's negative from negative infinity to negative 5 and 3 to infinity. Okay, my x-intercepts, negative 5, 0 and 3, 0. Okay, notice how that factors into my positive and negative. My x-intercepts, so my y-intercepts, rather, I plug in 0. Okay, so 0 plus 1 is 1. Absolute value of 1 is 1. Negative a half times 1 is negative a half. And then plus 2 is positive 1.5. You could do positive 3/2, your choice. Okay, end behavior, as x goes to infinity, f of x goes to negative infinity, arrows going down. As x goes to negative infinity, f of x goes to negative infinity. If you had these flipped around, if you did this line, the bottom line first, like you had it the reverse way for me, still 100% correct. Unless I specifically tell you in the future that I want you to do it negative infinity and then infinity, do it in whatever order you want. That doesn't really matter to me. It's almost like saying A and B and B and A, where it's like, guys, I don't really care how you do it. I just want to know the information, right? Okay. Okay, so again, make sure you have this 100%, and then I'm going to move on to the final one. This is going to be another you try. All right, last one I have for you. This is an exponential. Okay, f of x equals 3 to the x minus 2. This is similar to one I did for homework, okay? So go ahead, pause it, try to analyze this, and then in a moment, we'll take a look. All right. So folks, here's the information I'm looking for, okay? And if you need to do another quick pause, okay, if you need to do another quick pause for analysis, you can go ahead and do that, all right? But basically what I've been asking you is the exact same thing, Okay, domain, range, increasing, decreasing, some of this stuff right here. Okay, so if you need another pause, feel free to do that. I'm going to probably have the pause now up on the first pause that I gave for this question. But regardless, go ahead, pause if you need to. But I'm going to now go through the analysis on this one. Okay, and I'll keep it zoomed out a little bit more. How about like this? All right, domain, again, it's the trick question basically. Everything. Okay, range. This one's actually tricky. So in this case, it's flattening out here at -2. It's never going to really get, and I know that's kind of hard to see based on the graph, so it's never going to actually get to -2. I invite you to take another look at the homework, okay? It's never going to actually get to -2. It's going to get really, really, really close, okay? So as it turns out, the range is -2 to infinity. And I know it seems kind of misleading there because it looks like it goes a little bit lower. If you said -3, I would also take that. But remember, on a quiz or a test, the graph's not going to be made by hand, so it's going to be a little bit clearer. Okay. Now, from left to right, it's always going up, always from left to right. So it's increasing from -infinity to infinity. It's decreasing nowhere. It's constant nowhere. Okay. Y-intercept. Where is it touching the y-axis? That's 0, -1. And we know that because, remember, I don't know if you remember learning about this in middle school, anything to the 0 power is always 1, and 1 minus 2 is -1, okay? End behavior. As x goes to -infinity, this thing is leveling off, okay? And what we're going to talk about is that's what you call a horizontal asymptote. It's leveling off at -2. And as x goes to infinity, where's f of x going to? Infinity, okay? Okay, absolute max or min? NA, there's no absolute max or min. There's no local max or min, okay? It's leveling off. There's never hitting an absolute max. It's never hitting a local max or min. And because it's always increasing, it never goes from increasing to decreasing or decreasing to increasing. And so therefore, there's no local maxima or minima either. Okay, so again, I really, really encourage you to use this video at your disposal. Go back and look through any of the timestamps, all right? Go back and kind of really break things down and make sure you really understood the kinds of things that I analyzed. Remember that on the Binder website, I have the complete analysis packet. We will be doing some of that in class, but we only have so much time to do it. So I need you to make the most of these resources. If you stuck out this whole video, like, really good job. I really commend you for having the grit to stick through the whole video. Please keep the questions going. Again, please see the description for the link to this resource, all right, and the timestamp so you can get through. Okay, but most of all, remember this. The one thing that I always say, remember, you can do it. All right, so keep the questions coming. Don't get discouraged. Keep loving math. Keep the questions coming, and have a wonderful day.